Hi all, let me see if you are live. Uh, yeah, okay, so we are live. So let's get started. Uh, the drill is the same. We will grind Leetcode DSA questions. So let's get started. Yeah, so I'm following this list and I will solve questions from this list. As of now, like whatever questions we have already solved, that those are marked as green. Okay. Uh, this question is also done. I'll just mark it green. TP planning stress. I'll just let me see. Check if a number is power of 10. Okay. Check if a number is power of 10. It's not in Leetcode or what? Power of 2, power of 16, power of 2. Okay, it's not a Leetcode question. Then let's wait. Here we have the average of source. Given a dictionary and CAD array, what is the longest word that can be found? Let's see if this question is present on this longest word in dictionary. I don't know. Connection seems very slow. Let's see. Hi all, Brandon. Wait for DSA questions. Our longest word in dictionary, given an array of strings words representing an English dictionary, I'll change to dark mode. Give me a minute. Yeah, okay. So the question is, given an array of strings words representing an English dictionary, return the longest word in words that can be built one character at a time, the other words in words. By one at a time. By is this the same question? Let me just check. Because right now I am only concerned about this specific list. Uh, no, here we are doing any category. Okay, let's avoid that first. Minimum path time, this of course is present in the code. Minimum path down, the code. This. I think we have solved minimum path sum for this back, but let's just revise it quickly. So minimum path sum given an n cross n. Let me yes. Given an n cross n grid filled with non-negative integers, find a path from top left to bottom right. We want to reach from top left to bottom right. Submissions. I think we have just solved it last week. Yeah, July 29th we have solved it. Anyway, let me just I'll just go through the solution once again. We are starting from the first cell, and we have to move to the uh, last cell, like top left to bottom right, and we can only move down or right. Okay, we can only move down or right, which basically means that, and we need to find the, or we need to minimize the sum of all numbers. Okay, sum of all numbers we need to minimize. So this is a helper function. R and C are our starting indices. N, M, and N are the original grid length and like a row and column number. And yeah, so here what is happening is that uh, obviously it should be valid. So if it is less than 0 or greater than equal to n, or c is less than 0 or c is greater than equal to n, we can just return. Now see, we have to take the maximum, we have to minimize the parcel, that is why we are taking the maximum value in here, okay? Now I can either go right. If I go right, what will happen is that I have the current value, so we'll take care of the current value when we are returning, okay? And I'll move to the right. So right basically means the row will stay the same, column will increase by 1, then n and grid. And if I have to move down, then row plus 1, like row will increase and column will stay the same, correct? And then we can return the minimum, right? But the current grid value we have to add, right? We are at wherever we are at, that value will add up to our solution. Apart from that, from right and down, we are trying to pick up the minimum number. This is why we have returned integer.max in here, okay? So this was just grid dot sorry grid dot length and grid of 0 dot length. Now what we will do is we will start at 0 comma 0 and comma n grid. This is it. This is the entire only thing we need to do in here. But of course, yeah, what is the issue? If it is less than 0, we can do that and map that. Then integer dot maximum value greater than the minimum. So starting from 0 0. Array, yes. I think we forgot the base condition. Base condition is when r is equal to n minus 1 and c is equal to n minus 1. We have reached the last index, so we'll just return 0 because first I will have to return the grid value as well. Grid of r and c. What is the issue? Have we done some mistake? We are taking minimum grid of 0 dot length, minimum path sum. But it is returning incorrect value. This should work. I'm not sure what is the issue here. Uh, Acha, wait. I think integer dot max value, when we are adding something to this now, it wraps around and returns the, like, if there is an overflow due to which this is causing issue. The overflow is causing issue in here. So let's do one thing to avoid the overflow. What if I return this by 2? Or I can do one thing this. I think return long. Yeah, the overflow was causing the issue. Then incompatible types, lossy. Okay, I think then this is fine. Wait, yeah, okay, this should be fine then. Alright, so now we just have to memorize it. Uh, yeah, let's memorize it. So we would need the sorry, we would need the 2D DP, right? So let me write DP new and we would pass the DP here. I don't think we need this part. Okay, that error was due to integer has to elevate to int. That is why DP. Now here I need to tell my DP is not filled. Current I equal to 0, ls I plus plus arrays dot fill dp of I is minus 1. Yeah, and here we will check if dp of rc not equal to minus 1. Let's just return dp of rc, and in here let's just return dp of rc. Again the same issue. Array, this would be equals to okay. So this base condition is also required. Let me just add note base condition, and in here we are preventing overflow. This is the basic this is the basic approach. Uh, this is the basic minimum path from approach. Okay, and we have done memoization. We can also tabulate our approach. Okay, we can also tabulate our approach. So let's try to tabulate our approach. Mm, So this is let's just comment this much. Okay. So now if you see for like um like our recursion that is going from 0 0 to m minus 1 m minus 1, right? Which essentially means that m minus 1 m minus 1 calculation is being done at the starting, right? So if you look at it, it is bottom. We are going for a bottom up approach. Okay. So I state the variables name also same, so that we can simply replace our code logic in here. Okay. C equal to n minus 1, c greater than or equal to 0, c minus minus. Now the base condition is r is equal to m minus 1. Okay, so basically here we are trying to look for the uh, last row. Okay, like where are the last row, which means we can only go right. Okay, wait. Here uh, we should take a DP as well. Yes, we can take the DP as well because we'll update the DP thread, right? So yeah, now we can just start and we save. If it is equal to, this is a base condition. Okay, so in the base condition we are saying dp of, sorry, dp of rc is equal to grad of rc. Okay, else if, else basically what we have added is dp of rc. So let's do one thing. Okay, so see, if we are at the last row, if we are at the last row, then we can only go right. We can only go right. Wait a minute. So if we can only go right, we'll add up this value and the right value. Correct? This is the right value. Else if c is equal to n minus 1, we can only go down. We can only go down. C. Else, if we are in some middle cells, then we would have about the same logic as we invoked above. Rid of RC plus math.men of dp of r plus 1c comma dp of c, sorry, rc plus 1. And yeah, so now we can just return dp of 0 0. That's what we were returning initially. So this is bottom bottom up approach. Okay. Yeah, so now this works. Let's move on to some next question. We'll mark it as done in here. I'm switching to light mode. I don't feel good in dark mode. Yeah, so this is done, right? Yeah, this is done. Let me just mark it as done. Okay. Find original array from double array. Find original array from double array. Now solving 2007. Find original array from double array. So what is the question? What does the question state? An integer array original is transformed. An integer array, okay, an integer array original is transformed into a double array changed by appending twice the value of every element in original. Integer array original is transformed into a doubled array. Okay, change. Achha, we have been given the change array by appending twice the value of every element in original and then randomly shuffling the resulting array. So we had 1, 3, 4. So they doubled every value. So like 2, 6, 8, and they added it, and it's a random shuffle of that stuff. Given an array changed, given an array changed, return original. If change is a doubled array, if change is not a doubled array, return an empty array. So doubled array obviously means that all the elements inside it would be even, correct? So it is saying return original change, return an empty array. Okay, return an empty array. All right. So what we can do is we can go through the this continuous double array by finding twice the value of every element in original. So even the number of elements in it should be doubled, right? Because even if the original array has one, then also there should be two elements, right? So the number of elements in change array should be doubled. So if n mod 2 is equal to 1, basically if it is If it has odd number of elements, it somewhere signifies that there was some issue. Like it is not a perfect changed array. Also, all the elements, not all the elements, but we should definitely have 50% of the elements greater even, right? But do we need that? Do we need that logic? I think yes, we do. Because in here, how do we check that it is not a double array? But even with that logic of 50% being even, we won't be able to figure this out, right? We have changed this one. Okay. Uh, Change is not a double array. So double array basically means that inside the array we will find the double of the element as well. Okay. So if 2 and 4 both exist, right? I see 2. I can let's see how will we figure this out. If I have original from double, I'm trying to solve it in my notepad first. Okay. So original from double, we have 1 3 4 2 6 8. 1 3 4 2 6 8, and output is 1 3 4. Okay. 1 3 4. But see, suppose we sort it. Okay, and then we say is double of 1 present. So initially, let's say we just prepare a hash map so we know all the elements present. So is double of 1 present? Yes, present. So maybe 1 is a part of original array. Okay, is double of 3 present? Yes, then that is a part of original array. Okay, so since 2 is the double of 1, we don't take it. But what if uh, okay, double of 2 is 4. 4 is also present. Okay, let's check the hints first. What hints? Or let's check the topics. Hash table, hash table, and gradient sorting. Okay, okay. Hmm. Let's see. Uh, let's take a hint. It says you should be able to delete elements and their double values until the array is empty. You should be able to delete elements and their double values until they. So if I delete 1 and its double value 3, I delete 3 and its double value 6. Okay, but if the array is something like 2 6 8 1 3 4, or let's say if I get 2 4, or let's say I get 2, let's say I get a 4 first, and then 6, and then 1 3 and 4. In any scenario, if I delete 4 and it's double stuff, 2 and it's double 4. Suppose I get, okay. So let's say, suppose I have 2 6 8 1 3 4. I start with 2 and I remove its doubled array. There is that one. Yeah. I delete that 2 and its double value 4. Okay. Then I have 6. I don't have its double. I have 8. I don't have its double. I have 1. I already deleted its double 2. Okay. This is logic is not working. Let's think more. We are given an array. We are given an array. Given an array changed. Okay. Okay. Hmm. And we can have all the positive numbers are allowed. Okay. So should we do one thing? Should we? I think sorting is important. If we sort, then this logic might apply what it is sharing in the hint. If we sort change, okay, so now it is sorted. And now this thing we should be able to delete elements and their double values until the array is empty. Delete elements and their doubled values. Okay. Okay. Suppose I will start iterating. So now I will need a frequency map of integer, integer, new hash map, and now we are checking all the numbers. So it is sorted, so we will get one first. So inside the frequency map, we are putting one and its frequency. And now let's try constructing the original array, which would be of size n by 2. Yeah, so for an x being changed, what I have to say is if frequency dot get was default. So what we are trying to look for 2 cross x. 2 cross x. So is equal to 0. Which means we so suppose let's say that I start with 1, 2, 3, 4, 6, 8. Now double of 1 must exist must exist in the array. Okay, double of 1 must exist in the array. Okay, so but if it does not exist, basically it will zero. If it is zero, if it does not exist, or let's speak in easy terms that if frequency dot contains the key 2 cross x, if it contains this key, then we return this. Okay, we return this because we are saying that we cannot form the original array. Otherwise, if it is present, let's do one thing. Let's go to the index, zeroth index. Let's add the current number where we are, and we will reduce its frequency -1. And if frequency dot get x equal to 0, frequency dot remove x, also for 2x we will decrease the frequency, and if frequency dot get 2 cross x is equal to 0, we will again remove 2 cross x. Okay, so this contains the logic was fine. And yeah, uh, so this should handle. After this we should return original. One more thing, we are forgotten to increment index, so let's just increment index. What is wrong here? Output is this, expected is this, right? We started from this. Okay, we are getting 1. Frequency contains key 2x, which is 2. Yes, it is 2. Original, we are placing 2 in the original, sorry, we are placing 1 in the original array. Then frequency dot put 1, so we are changing 1's frequency to 0, it's equal to 0, so we remove 1. Then we are changing 2's frequency to 0, it's equal to 0, so we remove it's equal to 0, yes, so we remove it, and we increment the index. So 1 and 2 are done, now we get 3. Now, array, wait, we'll get 2, right? So if it contains key, it does not contain key, so it will return. Okay, my bad. We are not actually removing the item from this array, right? So what I should essentially do is I should not do it like this. I should not remove the element, because equal to 0 would probably tell me that we have already encountered this. We have already used this. So let's just do equal equal to 0, then continue. Okay, so 2 equal to 0. Let's continue. 3. But this condition still holds true. We need the 2x if we are coming here. Okay, we may not have x for this condition if you see. Because 2 is double of 1. But if if we come for 3 or if we come for 4, the 2x must exist, correct? The 2x must exist. What is the issue? What is the issue with frequency dot contains p x 0 here for 2? So continue, then we come to 3, then we come to 3, get 3 equal to 0. No, then have to check for 2x. अरे अरे यार I I added wrong. Basically, it should be negative, right? If frequency does not contain the key, then we will return new. Yeah, my bad. But this is a good question. Runtime error, index out of bounds. Okay, let's see. Let's see what is wrong here. 1421. Okay, they are running 1421. So for 1421, this is coming out of bounds, right? We have done index plus equal to 1. When we created this, we created n by 2. Okay, what's wrong here? Let me check. Uh, Array, okay, again, one more issue is left. Since we are not actually removing the key in here, right? Contains key will probably always say yes, it contains the key, correct? For already checked indices as well. So what I have to do is I have to use here get or default. Basically, if it is equal to 0, right? Then we have to return empty this empty array. Frequency dot get or default. Okay, now I think I should be able to submit it. But it's a good question. So, अरे यार, again the same issue. What is the issue? 0100 0100 0100. So when we sort, we say 0001. Okay. So okay, so like 0 t and 1 1, like in the frequency map, and frequency of initially when x is 0, frequency 0 is t, so we use it. Now frequency of 0 plus 2 0 is equal to 3, which is equal to 0, so we add 0 to the original, this is fine. Then we update the frequency. Then we update the frequency. So for 0, we change the reduce the frequency. Again for this 0, we reduce frequency once more. So like basically in frequency map, 0 has only one occurrence right now. Okay. So the issue is due to 0, right? The issue is due to 0. So do we need a separate handling for zeros. If the number is equal to 0 and if frequency dot get basically if we have 0 there should be even number of zeros, right? There should be even number of zeros. If we have uneven or like less than 2, that would mean this. Otherwise, okay, let's try something once more. Okay, it is passed, but it is a great question, and there are some SKSs which we might forget, so we need to revisit it. So let me just note down the stuff. Wait, the question is find original array from doubled array. So what we are essentially doing is we are sorting and creating a frequency map, right? So yeah, starting and frequency and creating a frequency map. Also frequency should be greater than 0 and yeah, frequency should be greater than 0, then only we process it. If it is 0, then we don't process it. If it is greater than 0, then we process it. Also frequency of 2x should exist. So frequency should be given and frequency of 2x should be greater than 0, right? And s is for 0, so needs even frequency, so decrement in pairs, okay, and we decrement both x and 2x, and x and 2x, and yeah, if at any point I increase, we yeah, it should help me. Let's see. Okay, okay. It's a good question. We will revisit it surely. Let me just mark it. Yeah, marking it with orange because we need to revisit it. Magnetic force between two poles. Okay, what is the question number? What is the question number? 1552. Magnetic force between two walls. Between two balls. Okay. Okay. What is the question? In the universe Earth C137, Rick discovered a special form of magnetic force between two balls. If they are put in his new invented basket, okay, this Rick has n empty baskets. Okay, the ith basket is at position I. Morty has n balls, three balls, and needs to distribute the balls into the baskets such that minimum magnetic force between any two balls is maximum. It's a tough question. Let me reread it. In the universe Earth, Dick discovered a special form of magnetic force between two balls if they are put in his new invented basket. Okay, has n empty baskets. The ith basket is at position I. Okay, so okay, okay, 4, 7. Okay, each basket is in its position. Uh, So n is basically number of baskets is basically position dot left. Now not yes m balls and need to distribute the balls into the baskets such that minimum magnetic force between any two balls is maximum. Okay. We stated that magnetic force between is defined as position x minus y mod. So this, so whatever position it is in, this minus this is this minus. So the minimum of these should be maximum x minus y, x minus y, which means their location. So the minimum of this force should be the maximum force. Okay, between minimum and magnetic force should be the maximum. Okay, they stated ठीक है. So in here, basically, if you just forget about all the magnetic stuff, we have to maximize the minimum distance, right? The minimum distance between any two baskets, we need to maximize it. Let me just write it. Maximize the minimum distance between two balls, not baskets, two balls. What is m? Acha, m is the number of balls. Okay. So we have a specific number of balls and we need to minimize the maximum distance between those n balls. Okay. So since we have three balls here, distributed in 1, 4, 7. Okay. So the minimum distance between any two balls is calculated via this. So the minimum distance between any two balls is maximum. That's what we are looking at. Okay. I think it is very similar to some questions which I've done before, but I don't remember. Uh, but what we can do is, okay, positions can be anything. So basically, we can do binary search on the answer. Okay, so we can sort the positions. We can sort the positions. So let me just sort it. Arrays dot sort, yeah, position, and then the answer would basically the minimum distance between any two balls would be from maximum of this position to minimum, right? Because we will place balls within this area, right? So max position we need to figure out and min position we need to figure out. So let's initialize min with max value and max with, or sorry, we have already sorted, right? So we don't need to initialize. Max position basically means position of n minus 1, and min position basically means position of 0. That's it. Max position is this one, min position is this one. Whatever is given, it is done. So here one would be the max position, min would be this. Sorry, 1 is the min position, max is this. Okay. Now we have to do binary search on this within this range. Okay, we have got a range. We do binary search on a range, right? So now we can do our uh, binary search on this range. Okay, so binary search. Let's just create this. Low will be 1, high would be max minus minimum. Max position minus min position. Let's just give a comma. Yeah, low and high, and an answer as well. So we can initialize the answer with 1. We have to maximize the minimum distance between two balls. Okay, it should be maximum. Okay, now what we would do is now we would pick up a mid. Okay, now that mid we will try to check if we can place all m balls at least that mid distance apart or not. Okay, so while low less than equal to 5, we get a mid which is low plus 5 by 2. So what we will try to check is if if we can place all the M balls at least this much distance apart, at least mid distance apart. So let me write a different function, okay, where we pass the number of balls. Wait, first let's pass the position, number of balls, and yeah, position area as well. If we are able to, we are seeing that okay, we are able to place the ball, we are able to place the ball in this mid distance. Now we want to maximize, right? So now since mid is feasible, let's just take it as answer and let's try for a bigger distance, which means we will come to the right hand side or the greater part of the array. Otherwise, we will be at the smaller part. Okay, okay, we cannot. We have to try for smaller distance. Okay, and then we can return the answer. We can return the answer. Now we need to write the calculate function. Uh, Private Indian can place. We would take uh, the current distance, speed, and position. So we can simply simulate this. If, if you can place it, otherwise, if this becomes greater than equal to n, then we can return true. Otherwise, we will have to return false. This is a very famous question on binary search. I'm unable to recall which question it is extremely similar to, but it is similar to some question. Let's see the similar questions. Okay, balls with twice. Aggressive cows. Yes, aggressive cows. Okay, okay. So we are done with this one. What is the next question? What is the next question? Mm, let's solve this one. This is binary search. Okay. Implement SPOI. Implement SPOI. String to integer. Okay. Implement the my a2i string function which converts a string to a 32-bit signed integer. 32-bit 32-bit signed integer. Determine the sign by checking if the next character is minus or plus, assuming positivity if neither present. Read the integer by skipping leading zeros until a non-digit character is encountered or ended. If no digits were read, if no digits were read until a non okay, okay, okay. Then there is a zero. If the result is out of range, then the mean the range between DSA and long distance, and DSA. Okay. Okay. Again, since level of question, let's see what other questions do we have. Default 108655. Oh, okay. Okay, 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 okay. This is that average score of top students, top five students. or students top 5 marks. This I have done few days back only, and I think we can just remove it from this. Let's see. This is marked as done. Question is about a bishop on a chessboard and find minimum number of moves for bishop to reach the target. Okay, this is an interesting problem. Let's see what it is. Targeted bishop. Okay, it is not present on b4. Minimum moves to target. अच्छा, this one. This is what I think. Find the minimum number of moves for the bishop to reach the target. If it was impossible, I needed to return -1. Okay. Minimum moves to capture the queen. There is a one indexed 8 cross 8 chessboard containing two pieces given six integers A, B, C, D, E, F, where AB denotes the white position of the white rook, CD denotes the position of the white white bishop. White bishop. Where is the white bishop in here? Okay. EF denotes the position of the black king. Given that you can only move the white pieces, what are the minimum number of moves required to capture the black king? Moves can move any number of squares either vertically or horizontally, but cannot jump over other pieces. Moves can move any number of squares either vertically or horizontally, but cannot move over other pieces. Bishops can move any number of squares diagonally, cannot jump over other pieces. Move for bishop is vertical square that they can move to. The queen does not move. Okay. White 50, 1 3, 1 3. Okay, 1 3. In here. Okay, and then B3. Okay, we come here. We cannot kill because it will be, and then we can come here. Okay, anyway, screen does not move, so we just come here and we come here. One, one. Okay, for this, let's not see the answer. Let's try doing it. So in one move only, now we can capture. Okay, okay. Anyways, I'll get going. I'll solve this question and the other questions. Yeah, we'll stream some other day. For now, I'll close the stream.